Alright guys, welcome again. So just like I promised, I'm going to be making this video for the part 2 of the class we started, a man on a lift, which is a physics video. And we have that diagram like this. And we have explained that they have not watched the first video. Please, I just advise you to watch the previous video, which is part 1. So this is part 2 of the video. So we have done part 1. If the lift is moving downward, and number 2, if the lift is moving upward. Then we have number 3, that if the lift is stationary, and the last one, that if the rope in the lift, or sometimes I use elevator, suddenly cuts. So I've used this place for the case 3. Case 3. And that case 3 is if the lift is stationary. Now, as a student, JAMB WAEC student, what's the meaning of stationary? Stationary simply means what? Static, or stagnant, or not moving. Now, how in this works? If the lift is stationary, you will agree with me as a physics student, the thing that should come to your head when you hear stationary, static, something is not moving. Number 1, generally in physics, under VT graph is velocity time graph, know that your u because of what is 0, abi. And another thing is that your a is also equal to 0, yes or no? But from the what we start with from part A, no, we are not using u here, right? We have our a to because of 0. When a body is static or stationary, you note that acceleration due to gravity, acceleration is equal to 0. No, it's a very simple term. Another thing, under VT graph, when you hear a uniform motion, constant motion, or constant velocity, your acceleration is equal to 0. That means you are not accelerating, you are not moving. That's just the meaning. Do you understand? So you have to take note here that when the lift is what? Stationary, your a is equal to a 0. Yes or no? And let me now give you a very simple illustration. You know yourself that if this lift is not moving, or it is static, what does that mean? It means the weight of the what? Of the body of the man and the tension are equal. They are balanced. Do you understand? You know, the case 1 that we treated, when the weight is heavier or greater than the tension, the lift moves downward. Yes, no. And when the tension is heavier or greater than the what? Weight, the lift moves upward. Yes or no? Very good. So now that the lift is not moving, what does that imply? It means that the weight and the tension are equal. Shey you get? Very simple. So that means the tension is equal to the weight. There is no balance force. Even if you want to introduce your force F, ma, your a is equal to 0. So the force is all equal to what? Is 0. So your tension is equal to the weight. So you have T equal to mg. Do you understand? Very simple. Now, let me now introduce this, like, forgot to include in case 1 and case 2. In case 1, when the lift is moving downward, so the body will appear heavier than its true weight. That is the reason why the body was, or the man on that lift was able to pull the lift downward, which is another thing that to note. It means that the body appears heavier than its true weight. And for case 2, case 2 is when the lift is moving upward, yes or no? Yes. And at that moment we explain that the tension is what, is heavier or greater than the what, than the weight of the body, you know. So far the lift can move upward, it means that that body in it appears to be what, lighter. Do you understand? So and don't forget the example I gave, bucket full of water and you use handkerchief to carry the bucket. So if you can move it upward, it will look as if if someone is washing you, it will look as if there is no water in that what, in that bucket. So the body will appear lighter than its true weight. The body will appear lighter than its true weight. Do you understand? So this is for case 1 and for case 2. Then for case 3 here, when they are equal to each other, what does that mean? So the body we then exert is true weight. Do you understand? So that's just it. So then let's go to the last case, which is case 4. I think you understand. So now the case 4, what we have in case 4 is that if the rope in the lift suddenly cut, it's a very simple one. Case 4, if the rope suddenly cut, what will happen? If the rope suddenly cut, 2 things will happen. The body, now let me ask you this first question. When the rope in this lift suddenly cut, where will the lift move to? Will it move downward or upward? Downward, right? Correct. Maybe it moves upward, you will run away. Because if the rope cut and it's moving upward, no, it's not possible. Because acceleration due to gravity, we have to exert on it. You understand? What is gravity? Is what? Is the gravitational earth push on an object. So it will definitely move downward. So and if it's moving downward, it's having the same acceleration. What does that mean? It means that if the rope suddenly cut, your acceleration is equal to acceleration due to gravity. Do you get that now? So your A is equal to G if the rope suddenly cut, because it will be falling downward with a particular acceleration, and gravity will also exert on it equally. So that's the first thing you have to note there. If the rope suddenly cut, your A will be equal to G. And another thing you have to take note is that if the rope cut, where will it move to? Downward. Abi, very simple. And we have done it that the formula for a man to be moving downward in the lift is still equal to M bracket G minus A. Yes or no? This is the formula if it's moving downward, right? Now, so far that we have said that your A is equal to G, so we can say open bracket G minus G. Abi, so T will now be equal to M. G minus T will give us what? Is 0, and T M times 0 will give us is 0. Do you understand? So and that simply means for this, for the case 4, what we that mean is that the body we experience weightlessness. You know that if you have 100 people in that lift, if you don't suddenly cut, it will look as if there is nobody in the lift. So the body will appear or experience weightlessness. Do you understand? Alright, thank you very much. So in our next video, we are going to be explaining real questions from JAMB, many JAMB questions concerning this particular topic. Please make sure you watch the part 1 and part 2 to get every details of what we have explained. Thank you very much. Stay tuned, like, share, and subscribe. Please share to your friends that are writing UTME 2026. Thank you very much and stay blessed.